Dear students, Assalamu alaikum. Hope you are fine. Today we are going to have second class on geometrical optics. First of all, I welcome you to my class, that is Jaffar's tutorial. It's me, Jaffar Iqbal, Assistant Professor of Physics, English Medium Morning Shift at Geometrical Model College. Let us go for our topic, that is geometrical optics. We are having the second class on geometrical optics. We know that today we will study refraction at concave surface as well as convex surface. Let us see here. We can see it is a refracting surface. It is a transparent material of refractive index, that is N2, and here the medium of refractive index N1. O is the object. O is the object here, and APB is the refracting surface, concave refracting surface. This refracting surface is separating these two media, this media and this media. Okay, understand? So here OA is the incident ray. It is refracting along AD. It is refracting along AD, and the incident ray is indicated by the original ray is indicated by the red color. It is indicated by the red color, and that is AD is the refracted ray, and C is the center of curvature of the spherical surface. Okay. Then we join, that is CA, we join CA and we extend it up to E. So here this is the CAE is the normal to the point of incidence, and AD is the refracted ray. So here DAE, that is the angle of refraction. This is angle of refraction, and it is represented by R. Okay, and here CAE is the normal to the point of incidence, and OA is the incident ray. So the angle here CAO is the angle of incidence, that is I. Okay, and we extend this refracted ray, that is AE, is different, that is AD. We extend this AD refracted ray backward, and this backward extended ray meet the principal axis, that is here CP is the principal axis of this refracting surface. So AD, the extended portion of AD is meeting the principal axis at point B here. So here this is the object, and here B is the virtual image. B is the virtual image of the object. Here for our convenience, we consider that is N1 is equal to, here N2 is greater than N1. N2 is greater than N1. That is, this is the denser medium and this one is the rarer medium, and here N1 is equal to 1, that is, this is air, and since it is 1, so we consider N2 is equal to N. Understand? Here we see that is CAO is equal to angle I. CAO is equal to, that is angle of incidence I, and angle R is equal to DAE. DAE is the angle of refraction R. Okay, is equal to BAC. Is equal to BAC because this is vertical opposite angle. This angle is R, so BAC is the vertical opposite angle, and that's why BAC is equal to DAE. That is, if this angle is R, then this angle is also R. Okay. We know from the definition of refractive index, that is N is equal to sin I by sin R. We know this one. And for very small angle, that is sin I is equivalent to I. When the angle is very small, then sin theta. When theta is very small, then sin theta is equal to theta, is equivalent to theta. We know this one. So sin I is equivalent to I, and sin R is equivalent to R. Here let us consider that this aperture is very small, and that's why all the angles, angle of incidence I, angle of refraction R, all these are very small angles. We have very extended image, but basically this I and this R are very small angles. That's why sin I is equivalent to I and sin R is equivalent to R. So if we put this value, that is sin I is equal to I and sin R is equal to R. So therefore we get refractive index N is equal to I by R, or I is equal to N into R. That is equation number 1. Okay. So now let us consider this incident ray and normal to the point of incidence and the extended ray of the refracted ray, that is incident ray is making an angle gamma with the principal axis, and that is the refracted ray is making an angle beta with the principal axis, and the normal to the point of incidence is making an angle alpha with the principal axis. That means this angle is alpha, this angle is beta, and this angle is gamma. Okay, it is told here that is ACO is equal to alpha, ABO, that is ACO is equal to alpha, ABO is equal to beta, and AOB is equal to gamma. Let us come to the triangle ACO. Here, that is ACO, this triangle here. So in this triangle, for this triangle, that is AOP is the exterior angle, that is gamma is the exterior angle. So we know that is gamma is equal to I plus alpha, because the exterior angle of a triangle is equal to the sum of the two far interior angles. That's why gamma is equal to alpha plus I, or I is equal to gamma minus alpha. And in triangle BAC, come here, this triangle BAC, this triangle here, beta is the exterior angle, so we can write beta is equal to alpha plus R, that is R and alpha, so beta is equal to alpha plus R, or R is equal to beta minus alpha. Now putting this value of I and R, in equation number 1, that is, what is equation number 1? We see equation number 1 is that I is equal to NR. So we get I is equal to gamma minus alpha, and we get R is equal to beta minus alpha. So I is equal to gamma minus alpha N into beta minus alpha. We are putting the value of I and R in equation number 1. Now we have to come to the figure. That is, we know any angle is the ratio of the arc and radius. So here AP is the arc, and AP is the arc, and OP is the radius. For angle gamma, AP is the arc, OP is the radius. So AP by OP minus alpha here, AP is the arc and CP is the radius. So AP minus CP is equal to N. Beta is equal to AP by BP minus alpha, that is we know AP by CP. You see here AP is common in all factors, so we can divide both sides of this equation by AP. So we are getting 1 upon P minus 1 upon U is equal to N into 1 upon BP minus 1 upon CP. Okay. Now we have to come to the figure, that is OP. What is OP? This is the object. So we know that in case of surface, all the distances are measured from the pole. Here P is the pole of the refracting surface APB. So OP is the distance of the object, that is U, and it is positive. That is OP is equal to U, and CP, here CP is the radius of curvature. You have to remember that when the center of curvature is on the side of the image, then it will be negative. When the center of curvature is on the side of the image, then the center of curvature will be considered as negative. So here is the image and center of curvature. So that's why CP is equal to minus R and VP, that is here B is the position of the image, so VP is the distance of the image, and here the image is virtual image, that's why V is negative. So BP is equal to minus B. Now we can put the value of OP is equal to U, CP is equal to minus R, BP is equal to minus B in this equation. In this equation we can put, so 1 upon U minus CP is equal to minus 1 upon R, 1 upon U minus 1 by minus R is equal to A into 1 by minus B minus 1 by minus R. So after calculation we get that is N by B plus 1 upon U is equal to N minus 1 by R. Okay. So this equation is the equation of refraction at a concave surface. And at the concave surface when the refraction occurs, and this is the expression for refraction, this is the equation of refraction at a concave surface. We have got the equation of refraction at a concave surface. Now we can see the refraction at the convex surface. Here everything is same. Here the equation will be same, but the condition here, that is this refractive index, that is mu2, this is here mu2 is equal to 1, and the refractive index of the material of the transparent medium, that is this is the refracting surface, convex surface. Here mu1 denser, that is mu1 is the refractive index of the denser medium. So here mu2 is considered, that is mu2 is equal to 1, and that's why mu1 is equal to mu. So the same equation is here, that is mu by v. Here it was n, so instead of n we are using here mu. So mu by v plus 1 upon u is equal to mu minus 1 by r. The same equation for that means the equation for refraction at any spherical surface is mu by v plus 1 upon u is equal to mu minus 1 by r, or n by v plus 1 by u is equal to n minus 1 by r. So we have got the common equation. That is the same equation for refraction at the spherical surface, whether it is concave or convex. Now we will go for lens maker's formula. What is called lens? We know a lens is a transparent medium. Here we see the lens. A lens is a transparent medium bounded by two spherical surfaces. Here it is bounded by two spherical surfaces, and it is a biconvex lens. And we will deduce the lens maker's formula. That means the lens is made by using which formula? We will deduce this formula. Let us consider here the refractive index. Here is the object, that is O is the object, and there are here the refractive index of the material of the lens is n2, and here the medium whose refractive index is n1, here also n1, that means the same medium on the both sides of the lens. And AMB is the first refracting surface, and ANB is the second refracting surface. The radius of curvature of the first refracting surface, that is R1, and the radius of curvature of the second refracting surface, that is R2. Okay. Let us see how the refraction occurs here. Here, for our convenience, we consider n1 is equal to 1. That is this is here. On the both sides of the lens there is here, and here n2 is equal to n. We consider this one. So here O is the object, OM is the incident ray. Okay, and then Ni prime is the refracted ray. This is here, I prime is the image, and this image is formed in the material of the lens. Remember this one. This image is formed in the material of the lens, and this refraction occurs in the first surface, that is on the surface AMB. Okay, and then the refraction will occur in the second surface. In that case, this is very important that in that case, I prime, this is the real image for the first surface, but this will be the object for the refraction in the second surface. And here this is the final image, that is I is the final image. I is the final image, So we have to here, this is very important to remember that the image is real. The image is real and the object, when the object and image are on the both side of the lens, then one will be real and another will be virtual. Here the image is real. Obviously it is real because it is a convex lens, and when the image is formed behind the convex lens, the image is real. So the image is real. Since the image is real, so this will be the object and this will be the virtual object. This will be the virtual object for the refraction at the second surface, that is at the surface A and B. This is very important. That means we always know that the object is always real, but in this case the image is in this case the object is virtual. This is very important. Okay, so here O prime is the optical center. So here this distance, that is O prime, that is the distance of the object, and here V prime, that is the distance of the image for the refraction at the first surface, and then V prime is the distance of the object in the second surface, and V is the distance of the final image, that is the real image, final image. Okay, so this is the explanation of the figure, and let us go for calculation, finding the lens maker's formula. Here, for our convenience, we consider R1, capital R1 is equal to R1, and capital R2 is equal to R2, and N1 is equal to N, and N2 is equal to A. Okay. So we know that is the equation of refraction at the spherical surface. We know that is the common equation. So when refraction occurs at this surface, then what happens? That is, for refraction at the surface AMB, that is N by V prime. Okay, N by V prime, because refraction is occurring, that is image is in this image is we consider that when refraction occurs at this surface, there is no air. Total area is covered by the material of the lens. So this image is formed on the material of the lens. So here the refractive index of the material of the lens is N. So N by V prime plus 1 upon U is equal to N minus 1 into 1 upon R1. It was 1 upon R, so it is here radius of curvature is R1, so it is 1 upon R1. That is equation number 1. Okay, and then we will go for the refraction at the second surface, that is at A and B surface. Okay, here this is the image and there this is the object. So here that is N by minus V prime. Why N by minus V prime? Because here the object is in the lens. So diffraction index of the material divided by the distance of the image or object. Here the object in the material. So that is N by minus V prime plus 1 upon B. Why 1 upon B? Because here this is the image and diffraction index. The image is in the air. Here the diffraction index of air is 1. So 1 by B, that is N by minus V prime plus 1 by B is equal to minus N minus 1. Since the object is virtual, that's why the negative sign comes here. Minus N minus 1 upon R2. The radius of curvature of this surface is R2. Okay, so we get two equations. This is equation number 2. Now adding equation 1 and equation 2, we get, that is 1 upon B plus 1 upon E is equal to N minus 1 into 1 upon R1 minus 1 upon R2. That's the equation number 3. This is the general equation of lens for refraction. Now, if the object is at infinity, that is U is equal to infinity, then we know that the image will be formed at the principal focus, that is V is equal to F. So we put the value, that is 1 upon U is equal to 0 because 1 by infinity is equal to 0. So, and V is equal to F, so 1 upon F is equal to N minus 1 into 1 upon R1 minus 1 upon R2. That is equation number 4. So this equation 4 is the lens maker's formula. I hope you understood the equation for making of lens. You understood? So we go for solving one mathematical problem. Let us see here what is the mathematical problem. The radius of curvature of a biconvex lens of refractive index 1.5 are 15 centimeter and 30 centimeter respectively. Number 1, determine the focal length of the lens in air. Number 2, what will be the focal length of the lens in water of refractive index 4/3. Solution, here R1 is equal to 15 centimeter, it is given. R2 is equal to, remember this one, for convex lens, it is convex lens. For convex lens, R1 is positive and R2 is negative. So R2 is equal to minus 30 centimeter, N is equal to 1.5, it is given. So F is equal to what? Very simple, that is 1 upon, we know 1 upon F is equal to N minus 1, we have to use lens maker's formula. So 1 upon F is equal to N minus 1 into 1 upon R1 minus 1 upon R2 is equal to 1.5 minus 1 upon 15 centimeter minus 1 upon minus 30 centimeter, and having calculation we get that is 1/20 centimeter inverse 1, that is F is equal to 20 centimeter. That means the focal length of the lens in air is 20 centimeter. Question number 2, what will be the focal length of the lens in water of refractive index 4/3? Here refractive index of water is 4/3. So let us see question number 2. So what is here? R1 is equal to 15 centimeter, R2 is equal to minus 30 centimeter. Refractive index of glass with respect to water. Refractive index of glass with respect to water. Here it will be refractive index of glass with respect to air. Here it will not be W, it will be air. It will be A. It will be A. So refractive index of glass with respect to air, that is 1.5, and F is equal to what? Okay. So now we 1 upon FW, that is focal length of the lens in water, is equal to WNG minus the refractive index of glass with respect to water. We have to use this one, minus 1 into 1 upon R1 minus 1 upon R2. It means that is or 1 upon FW is equal to NG by NW. This is WNG. So NG by NW minus 1 upon R1 minus 1 upon R2. NG 3/2, that is 1.5 3/2, and NW 4/3 minus 1 upon 15 centimeter plus 1 upon 30 centimeter. So having calculation we get FW is equal to 80 centimeter is equal to 0.8 meter. So I think you understood the math, and by solving the mathematical problem you came to know the use of lens maker's formula. So we are almost at the end of the class. Let us see what we learned today's discussion, that is refraction at spherical surface. We learned refraction at spherical surface, and then lens maker's formula. We deduce lens maker's formula and then solving mathematical problem. So we think we are almost I think that you understood the class well, and I am going to finish the class. In the next class we will have more topics with variety. Till then, Allah Hafiz. Assalamu alaikum wa rahmatullah.